Steve Williams here. I'm at American Standard Circuits. Today I'm with John Bushy, Director of Technology here. Hey John, how you doing?
Very well, Steve.
So recently you and I were at a function where you were doing a technology presentation to an audience and you were talking about some new equipment that American Standard has just put in place. One of the things I found really fascinating was some kind of a microrectifier. Can you fill us in on what that is and how it helps you?
Absolutely, Steve. We're getting asked nowadays to do a lot of what we'd call selective gold plating. In those cases, we're trying to meet two different requirements on the same panel. One, we're trying to provide a solderable gold surface that won't damage or embrittle the solder joint for the components. And the second is basically a thicker gold ball wire bondable surface, obviously for gold ball wire bonding. The differences in thicknesses are generally we like to be less than 10 microinches of gold for solderability purposes. IPC, I believe, agrees in that respect. And for gold ball wire bonding, it may range anywhere from 50 to over 150 microinches. So you'll see the significant difference in the amount of area that we're plating to do those two things, and it's for some very specific reasons. Now, to give you a little bit of background, generally when we're talking about gold ball wire bondable gold, we're talking about a soft pure gold, and generally that's a type 3 with 99.90 purity and Knoop hardness of less than 90. We control that through monthly analysis by our chemistry supplier, and it allows us to do this plating in a reliable fashion to give people consistent gold ball wire bonding results. Now, when we do that for a full-size panel in a full panel plating configuration to be able to provide the solderable surfaces and the protection to those surfaces, this is an example. This would be an 18 by 24 inch panel, but we've decreased the scale a little bit for demonstration purposes. But in this case, it would be a 432 square inches for a full 18 by 24. This actual image is about 303 square inches. So in essence, if we're talking about soft gold plating, which generally in our case uses 3 amps per square foot, which is the desired current density, we're talking at plating roughly 6 amps. In this instance, we're using a plating rectifier that goes up to 10 amps. The problem comes in is when people want those selective areas, which tend to be very small in size, as demonstrated by what is the selective artwork for this particular job. You can see how sparse the plated area is. You can see that the borders are even reduced, and we're not using the thieving area that we were using on that particular design. Well, obviously, there's a very good reason for that. Gold at 150 microinches thick is extremely expensive, and you have to control costs for your customer because obviously somebody's got to pay the bill. In this particular instance, we go from roughly 70% of plated area down to about 7.2. In those cases, if we were using a relatively large rectifier at 10 amps, we would have extreme difficulty getting down to those low current settings with the resolution of a rectifier designed to be able to plate that high. The other issue is that when you start to plate at the very bottom end of a rectifier's capability, you start to get into its noise. And as you get into its noise, it starts to create plating anomalies and other issues. In this case, when we go to selective plate, we utilize a specific, we'll call it a microrectifier. And basically what it is a very low current rectifier designed for very fine resolution control, in this instance about 0.1 milliamps resolution. And it's generally used when we're plating very small areas. In some cases, when we talk about the board area specifically, we're plating less than 10 square inches. In this example, we're talking about 31 when we calculate in all of the panel border area. And if you imagine this is an 18 by 24 inch panel, you kind of get a sense for it. This is just another way that we're able to provide a surface finish for our customer and do it reliably. We felt it was absolutely critical, which is one of the reasons we teamed with Dynatronics on this and came up with an excellent solution.
Awesome, John. I appreciate that. So, I mean, this is significant. This is a 10x reduction in surface area, right?
Absolutely.
And normally, you'd be frying all these isolated.
That's exactly what happens. And in that case, the bath becomes very inefficient. It starts to generate hydrogen that creates localized alkalinity or high alkalinity, which breaks down the resist and gives you imaging problems. Basically, your circuitry or your pads are no longer the same size as what was intended, and you have subsequent etching problems. So this is really the right way for us to go about this.
And you guys have added a bunch of new equipment here recently to help your capabilities and increase your technology. So hopefully we'll be talking about some of those in future sessions.
Absolutely.
Totally appreciate this. This is fantastic, and I look forward to seeing it in action.
Excellent, Steve. Thanks again.
Absolutely. Once again, Steve Williams, John Bushy, American Standard Circuits, and thanks for watching.